All right, guys, this is the very last section that we're learning this year. So in 5.6, which was the section before this, we learned how to derive inverse trig, which is all these formulas right here. Now we can go backwards, okay? But the lucky thing here for you guys is you only need to know 3 formulas going backwards. All of this is on your formula sheet, okay? So basically, when all else fails, when you can't just use u and du, you think, well, is it one of these 3 integrals that integrates to inverse trig? Okay, so not all of these below require one of the 3 formulas above. Use your formula sheet to help. Remember that formula sheet is listed under classroom, so you should have that printed out or somewhere close to you that you can keep referring back to it. So for number 1, all right, looking at this function, you have a fraction, you have a root. Automatically try to make u the inside. Okay, the derivative would be negative 2x dx. That does not work. Okay, that does not work because you don't have an x in the numerator and you can't just put that in. So when that doesn't work, you think to yourself, wait a second, is it one of these 3 up here? Okay, it actually resembles the first one. A is a constant, so 4 is the a squared, and the u is always the variable term. That's the x squared. So once you realize you have to use one of these 3 formulas, you're writing out just a tad more. So you're writing out what your u squared is, which is x squared. You're writing out u, which is x. You're writing out your du, which is dx. You're also writing out what your a squared is, which is 4. And you're writing out what a is, which is 2. So you don't have to put anything in because your du is just dx, and you already have that. So the numerator becomes du. The denominator becomes root a squared minus u squared, which is this formula right up here. So that integrates to arc sine of u, which is x, this is why we write it all out, over a, which is 2, plus c. All right, plus, that's a plus c. That's horrible. Come on, Bo, come on. Okay. Plus c. All right. Now, if we look at example 6 down here, it looks very similar to number 1 that we just did, but you can make u just the inside of the root, and that will work because the derivative is negative 2x dx, and you have an x dx in there. You just need to put a negative 2 in and multiply by negative 1/2 on the outside. So that ends up being negative 1/2 the integral of du over root u. Okay, now what you have to do with that is you have to rewrite it as u to the negative 1/2 to integrate it. So bring that power up. Then that integrates to u to the positive 1/2 when you add 1. And divide by 1/2 is the same thing as multiplying by 2. These 2's will cancel. You're left with negative u to the 1/2, or in other words, negative root u plus c. So there's your answer to number 6. And 1 and 6 look very similar. The difference is in x, and very different methods in terms of integrating. All right, so let's actually go to number 4. We're going to skip around a little bit. So seeing that you have a fraction here, you would typically try u to be what? The denominator. All right, you're hoping that works. Let's see, when I take the derivative, I end up getting 2x dx, and look at that. It works because the x dx is in there. You just need to put a 2 in and a 1/2 on the outside. you end up integrating du over u, and du over u, based on your formula sheet, integrates to the natural log of the absolute value of u plus c. Okay. Now, going back to number 2. All right, if we try to make u the denominator without actually writing it out, would it work? The du would have an x in it, because when you derive this, you get 18x, and there's no x in there. So that's when you say to yourself, okay, normal u and du won't work. Does it look like one of these last 3 ones? Yes, it looks like the second one, because there's no square root. So once you realize you're using one of these last 3 formulas, you write down your u squared, which is the variable term, so 9x squared. Your u would be the square root of that, which is 3x. Your du would be 3dx. Your a squared is the number, which would be 2. And your a is the square root of that, which is root 2. So you look and say, do I have everything? Well, to complete my du, I need to be 3dx. So I have to put a 3 in, which means a 1/3 goes on the outside. You're left with the integral of du over a squared plus u squared. And that integrates to 1 over a. So it'd be 1 over 3 times 1 over a. So it'd be 1 over root 2. So out in front you have 1 over 3 root 2. Arctangent of u, which is 3x, over a, which is root 2, plus c. And we're going to let you leave it with the square root in the denominator at this point, so you don't have to rationalize anymore. All right, and last but not least, the other example that we want to show you here is, once again, if you try to make u the inside of the root, you need there to be an 8x dx in the numerator. The x should be up here, not down there. So the normal u and du doesn't work. So then you say to yourself, does it look like one of these last 3 inverse trig functions? It actually looks like the third one, because your variable term is in front in the back, just like this one. So once you realize you have to use one of those 3, you write down your u squared, your u, your du, your a squared, and your a. So u squared would be 4x squared. U would be the square root of that, which is 2x. Du is the derivative of u, which is 2dx. A squared is 9. A is 3. So to complete my du, I needed to be 2dx. So I'm going to put a 2 in there, but guess what? Based on the formula, it should be u on the bottom here. To be u for our problem, it has to be 2x, and it's only x. So you have to put a 2 in there also, which means you do not have to put anything on the outside, because you technically put a 2 on the top and a 2 on the bottom. It's like putting in 1. So you're done having to put anything in. You don't have to compensate, because you kind of already did. Oh my gosh, something is going on with my mouth. Oh, jeez. Okay. It's like ghost in here or something. All right. So you have a u square root of u squared minus a squared. Okay. And this integrates to 1 over a. So 1 over 3 arcsecant of the absolute value of u, which is 2x. I'm following this formula right here. Over a, which is over 3, plus c. All right, there you go. So there's a bunch that I have you practicing. Let's just go through and quickly do just a couple of them. Make sure you get the hang of it. I'm going to actually look at number 11. When you have a fraction, your first thought should be trying to make u what? The full denominator. When I take the derivative, I get 3 e to the 3x dx. And I know I'm on the right track because look, I have the e to the 3x dx. I put a 3 in, I multiply by 1/3 on the outside. How did I know the derivative of e to the 3x? Well, it's on your formula sheet. You keep it the same times the derivative of the power. So this ends up being 1/3. I'm not doing that. The integral of du over u. My mouse is going nuts. Okay. So d over u integrates to the natural log of the absolute value of u plus c. Now, what we're going to do is we're going to go back to number 10. What is the difference between 10 and 11? They look really similar, but what's the difference? Because this power is different, you're using a totally different method. You can't just make u this inside because your du would have an e to the 6x in the top, and you can't change that. So this is one of your last resorts that we learned in this section. You have a u squared, a u, a du, and oh, is somebody punking me right now? Okay, we have an a squared and an a. Okay, u squared is a variable term, e to the 6x. U would be the square root of that is e to the 3x. Your derivative is 3 e to the 3x dx. Okay, your a squared is the number, your a is the square root of that, which is 2. To complete your du, you need to be 3 e to the 3x. So I have to put a 3 in here, which means a 1/3 goes on the outside. And here's what we have. The numerator is your du. The denominator is a squared plus u squared. So if you look at the, I was saying, if you look at the front of your sheet, this is actually, this is u squared. This is actually the second formula, which turns into arctangent. So it's 1/3 times 1 over a. So times 1 over a, so 1 over 2. Which is e to the 3x over a plus c. So it ends up being 1/6 arctangent e to the 3x over 2. You know what? I think somebody's telling me to call it a day. I'm stopping after this example. This is ridiculous. You're welcome. Over 2 plus c. So here's your final answer. I will post the rest of the notes if you want to try these as practice, but you have practice problems on a review sheet. And basically your last assessment is going to be next Friday, and it's going to be some derivative problems and some integration problems. So you just got to know, you have a formula sheet, you just got to know what formula to apply. That's it. Okay.